Okay, we're in section 8.1, where this section deals with model inverses and joint variation. So, chapter 8 talks about, it deals with being able to look at rational functions. And to start with, we're going to take a look at both direct variation, which in review is written as the equation y equals a times x, where a is what is considered a constant of variation. And then we're going to look at inverse variation, where we have y equals a divided by x. And the reason why they call that inverse variation is because it's the inverse of direct variation. The reason why they can say that is because if we remember from other chapters, if we try to find the inverse of a particular function, we flip both the x and the y and then still solve for y. So if I were to do it to this one here, I would say that this would be x equals a y, and then when I solve for y. So that's where that comes from. So for here, I have, again, my a is my constant of variation. And the first part of the homework, they want you to be able they want you to be able to classify whether the equation is a direct variation, inverse variation, or neither. So direct variation looks like this, and then inverse variation looks like that. So if it looks like either one of those things, we can classify it as a direct variation or inverse variation. If it does not look like either one of those two, we can say that it's neither. So for a, if I solve for y, I get y equals 9 over x. And that one looks like an inverse, so we're going to say it's inverse variation. Here I'm going to solve for y, so I get y equals x plus 14. Doesn't look like either one of those two, so I can write neither. And then for c, if I multiply both sides by 10, I get y equals 10x, and that looks like a direct variation. Okay. Here I have directions that state that write an inverse variation equation and or model. It says the variables x and y vary invertly. So that means that it's going to look like x equals a over x. It says write an equation that relates x and y given their values, then find y when x equals 2. So, for example, A, they say x equals 6 and y equals 5. So the only variable that we do not know what it is a. So, but we can use these values and incorporate with this equation of y equals a over x by substituting y and x and then solving for a. So my y is 5, which then equals a divided by 6. So I want to find out what a equals. So if I multiply both sides by 6, my a is going to equal 30. So that means my equation is going to be y equals 30 over x. So that's the first part. The second part is they want to know what y is going to be when x is 2. So when x is 2, or when x is 2, my y is going to be 30 divided by 2, which is 15. Okay? Same thing goes for b. I'm going to use, again, y equals a over x. I'm going to take 1 divided by 4 and equals a divided by 24. If I multiply 24 to both sides, I get a equals 6. And then I can write my equation as y equals 6 over x. So that's the first part. Second part is they want to know what y is going to be when x equals 2. So I get 6 divided by 2, which then y will equal 3. Okay. Here, I got A, B, and C, and what A, B, and C are is T-charts with X, Y data on it. And what they want us to do is to show if either of the data is a direct variation, an inverse variation, or neither. They want us to, if it is um, either one of the direct variation or inverse variation, they want to know what equation we can write with. So here's a little note. If we're trying to find direct variation, each value of y, and if we divide it by x, will all be the same. They must. So if I have, for example, for example A, I got 132 divided by 12. That result will give me 11. I got 198 divided by 18. That'll also give me 11. If I had 253 divided by 23, that does give me 11. 319 divided by 29 is 11, and 374 divided by 34 is also 11. So since they are all the same, I can conclude that this is a direct variation. And I can write this as the equation y equals 11x. Okay? But if example A, say it was like 11, 11, 11, and then all of a sudden I got a 10, then I can say that that is not a direct variation, or because it didn't show up with, it showed up with a different value for its divisor. Now, if you're going to look for inverse, you must have x times y all be the same. So let's take a look at example B. First off, let's take a look and see if we have a direct variation. So if I go 15 times 35, I get roughly 0.43. So I got 0.43. Now I got 24 divided by 40. Now I get 0.6. So now that already proves to me that it's not a direct variation. So let's see if it's an inverse variation. So I'm going to say 35 times 15 gives me 525. Now if I go to 40 times 24, I get 960. So two different values there. So now it shows that's not an inverse either. So I can write neither. Okay. Looking at this one, I get 144 divided by 12. I get 12. And I get 225 divided by 15. And I get 15. So this proves that this is not a direct variation. So if I go 12 times 144, I get 1728. And I get 15 times 225, and I get 3375. So it doesn't hold up in direct variation, doesn't hold off in inverse. This is also neither. Okay? Another thing we're going to talk about is we're going to talk about joint variation, where we're going to add an additional variable in the sequence. So the direction says is that the variable z varies jointly with x and y. It says write a joint variation equation for the given values. Then evaluate when x equals 6 and y equals 2. So this is very similar to what we were talking about on the first page, but except now we're just adding another variable to it. So it says that it varies jointly, so that means that z is going to equal a because we still need that constant of variation, and it's going to be x times y. So here for a, we're going to use this equation, but we don't know what a is, but we know what z is, and that equals, and then we got a multiplied by -4 and multiplied by 5. So let's solve for a for this. Now I got 60 equals a times -20. Dividing both sides by -20, I get a equals -3. So to write this equation, I'm going to get z equals negative 3xy. Now, they want to know what this is going to be when x is 6 and y is 2. So I'm going to say negative 3 times 6 times 2. And here z is going to equal a negative 36. Now, if I look at example B, again, I'm going to do the exact same thing. I'm going to use this equation, and then I'm just going to first substitute in these values in for x, y, and z and solve for a. So let's see here. So I got 20 equals a times, this would be what, negative 1/4. So if I multiply by a negative 4 on both sides, a is going to equal a negative 80. So I'm going to write this equation as z equals negative 80 times xy. And then they want to know what z is going to equal when x is 6 and y is 2. So here, z is going to equal, if I multiply those together, it's going to be a negative 960. Okay. Last thing that we're going to talk about is they want you to compare different types of variations by writing equations for the different relationships. So for example 1, it says x varies inversely with y and directly with z. So again, here's a note. Make sure that a is involved in the equation. Even though it doesn't say it in the example, your constant of variation will be part of your equation in this case. So here, x equals inversely with y, so that means it's going to be a divided by y, and then directly with z. So z is going to be on the top here. So that's how you write this equation. If you go r varies directly with the cube of s and inversely with t and u, you can write it as r equals, and then you have your constant of variation, which is directly with the cube of s, and then it's inversely, which is going to be divided by t and u. So that's how you write this equation. So a lot of it is just being able to decode what they are saying in the story problem and be able to write the equation. And that is how we model inverses and joint variation. Hope this helps. Till next time.